Okay. Welcome everyone to our first technical meeting for the year 2022. On behalf of the South African Coal Processing Society, I would like to wish everyone a happy and fruitful new year. We are looking forward to great growth in the coal industry with new innovations as well as improved technologies. For today, I would like to also mention that we are looking into having the annual dinner for 2022. So basically 2 years has passed since we had our last dinner, and it will be an honor to have your presence this year. Please look out for further communication regarding the dinner through your emails and our social media platforms, which are Facebook, Twitter, as well as LinkedIn. So for today, our presentation is on the low-cut SX10 spiral and Optima classifier combination, presented by Christina Ramothabi and Franco Di Fenter. You would remember, I guess, those who were able to join us last year for our conference, this presentation was given, but there could be some new information that would be, fruitful for all of us today. So I will just give their brief bios before I hand over to them. I will start with Christina's. So Christina is a general manager, process engineering at Multitech. She has over 15 years working experience in the mineral processing industry. Her field of expertise includes equipment sales, project management, commissioning, plant design and optimization, research, test work on processing equipment, including spirals, cyclones, classifiers, shaking tables, screens, and magnetic separators. Christina holds a master's degree in project management, an honors degree in metallurgy from University of Pretoria, a BTech degree in chemical engineering from the Vaal University of Technology. She is registered with EXA as a technologist. Franco obtained a Bachelor's of Engineering in Chemical Engineering with the Minerals Processing at the end of 2019, where he graduated top of his class at the Northwest University. Thereafter, he obtained a master's degree in Chemical Engineering in the beginning of 2021, with distinctions also from the Northwest University. Currently, he is an associate at Gravitas Minerals, where he continues to live out his passion for minerals processing, R&D, as well as people. He believes that South Africa's mineral processing industry has the potential to be the best in the world, and he would like to be part of developing the industry in order to achieve that. So I think with that, I will hand over to our presenters, but I would also like to just remind everyone online that you are able to post your questions. Just use our chats, and that we will attend to all the questions at the end of the presentation. So over to you, Christina and Franco.
Thank you, Refilwe, for the introduction and the opportunity to present. Welcome, everybody, and a very good afternoon to you all. Our presentation is titled The SX10 Spiral and Optima Classifier Combination in a Fine Circuit. So as we all know, spirals and classifiers are one of the technologies that get utilized, like in beneficiation of fine coals. So a choice of one technology over the other for the longest of time has always been around like the type of quality of product that's desired. So for where low cuts have typically been required, classifiers have always been chosen over spirals. But then recently, with recent developments like in spirals can now also produce a low cut. So now a question to operations, like if you desire a high quality product or a low cut, now that spirals can also produce a low cut, the question is, which technology is the right one for you? Is it the spiral or is it the Optima? Another question to really ponder on while we're going through the presentation is it really necessary for us to always like have these two technologies like compete against each other, like for a position in a circuit? Or is there an opportunity for these two technologies to complement each other and coexist like in a circuit? So this is the outline of the presentation. I'm going to cover introduction, objectives, experimental plan, and a portion of the results. I will cover the results on the SX10, then hand over to Franco to take us through the results on the Optima. And then he will also share a bit of financial implications that we've done like for this work, as well as conclude and share some recommendations. So recent years have seen an increase in the use of low-cut spirals and classifiers like in the South African fine coal processing industry. This is especially seen in wash plants that produce both export and Eskom quality product. I think the benefit of a diversified product range can actually be seen here on table 1. As we can see, operations stand to actually make more revenue by producing a diversified product or an export quality product, like as you can actually see there, like in terms of the rands per ton. So regarding the two technologies, like it has been shown that when processing fine coal, each technology has its own benefits. Now, emanating from the background that I've just now shared, the aim of this work was to determine the best combined fine coal circuit to produce both an export and an Eskom quality product. So therefore, the SX10 and Optima classifier were tested to address the following questions. Number 1, we wanted to establish which technology is best suited to produce the export quality product. Is it the SX10 spiral or is it the Optima? Number 2, we also wanted to understand the best fine configuration to produce these two products. Is it like with the Optima first, followed by the spiral, or is it the spiral first, followed by the Optima? As well as to understand the overall performance and financial implications. So figure 1 here shows the scenarios that were tested like for this test work. Number 1, for scenario 1, we tested the raw material on the SX10 like as is. And as you can see, the top size there, it was -2 millimeter. The material was deslimed and the bottom size was 150 micron. And another portion of the raw feed was presented on the Optima. So then after doing this preliminary individual test on the two technologies, the results were compared to each other. And in terms of qualities, both technologies produce similar quality products. However, the results indicated that the Optima had achieved a much higher yield than the spirals, like on the roughing stage. It was then decided that for scenario 3, for configuring the circuit, it would be best to have the Optima become the primary stage and followed by the SX10 spiral. And two products like are produced like from this circuit as shown. So the first product that would actually be the high quality export product, and the product 2 would actually be the Eskom product like produced by the spiral. So on this section, I'm going to share a little bit about how the test was conducted, as well as to share the results achieved on the SX10 spiral. The SX10 spiral, it's the low-cut version of the Multitech spiral range. As the name says, the SX10 has 10 tens and it's equipped with 2 repulpers like on the body of the spiral. So after each repulper, there is an auto reject port that basically diverts the discard that has already been separated into the center column. So basically that helps to free up space and increase the surface area, makes more area available for material to get cleaned. So in a nutshell, that's a little bit about the physical features of the SX10. In terms of testing, figure 2 here shows the spiral test rig and mouth organ setup that was utilized for this work. The SX10 spiral was tested in a closed loop with a distributor and a pump as shown there like on the first figure. And the spiral was fed around 3 tons an hour at 35%, so it's like by weight. Each test was run until steady state condition had been achieved. and the sampling was done utilizing the mouth organ. So the clean coal was high, or just like for info for other people that don't understand how the mouth organ works, because this is coal, the high concentration of clean coal will actually be distributed more on the H fraction, and the distribution or the concentration of clean coal will actually decrease as you move from H2 to the A fraction. So figure 3 here shows the test work results on the SX test file. Like I've said, we've done like the test like with the raw feed. So this is the results like from that test. As you can see here, the CV was upgraded from 19.24 to about 26 and a half. This met the RB2 specification. Similarly, the ash was downgraded from 33.81 to about 16.6%, and this was achieved at a yield of about 29%. Figure 4 here shows the secondary run. Like I've explained, for second configuration, it was decided that we would have the Optima first, and then the discard from the Optima was the material that was sent to this particular run. And from this run, we can see that the SX10, the product met ESCOM specification. The CV was upgraded from a CV of about 12.6 to about 21.67. Similarly, the ash was downgraded from 51 to about 21.1 in the product. This was achieved at a mass yield of 45.3%. So now on this section, I'm going to hand over to Franco to take us through the results achieved on the Optima. Franco, over to you.
Thank you so much, Christina. Hello, everybody, and welcome. It's an absolute privilege for me to be a part of this technical session and to discuss a little bit more on the Optima that we've been developing here at Gravitas. So I'm just going to begin with a brief overview of what the Optima is, and then we'll have a look on the results that we achieved during the testing of these samples. So the Optima is a hindered settler that comprises of 3 main sections. And if you look at figure 5, you'll see the physical setup to the left in figure 5, and then a schematic of the Optima to the right. So as I mentioned, the Optima comprises of 3 main sections, the first of which is section A. That is the fluidization chamber. That is where your fluidized water is introduced into the unit, and the fluidized water is then introduced into section B, which is your fluidization chamber via nozzles. So in the fluidization chamber, fluidized bed chamber, excuse me, that is where most of your separation occurs, where your more dense material will sink and then your less dense material will float. In this case, it is the good coal that will float to your overflow. The third section of the Optima is the top section, section C, which is our recovery zone. As you'll note, the recovery zone has a bigger diameter than the fluidized bed zone. This increase in diameter leads to a decrease in the upward velocity of your flow, which then in turn gives a chance to particles to settle if need be. So between your upper and your lower zones, between zone B and C, that is where we typically see the formation of the autogeneous dense media zone. And then the autogeneous dense media zone also aids in separation, as particles less dense than the zone will float and more dense than the zone will sink through it. For the purpose of these test runs, A slurry was fed using a slurry feed pump at around 15% solids and a feed rate of 1,000 to 1,300 liters an hour. The fluidization rate was held constant at a rate of 400 liters per hour, where a relative density set point was used to control the Optima underflow valve, and that was set at 1.4. Looking at the results obtained from the test work, it can be seen that the feed, just to remind you, the feed top size was at 2 millimeters and then the bottom size was at 150 microns. So the feed was introduced and had a CV of 18.6 megajoules per kilogram and an ash content of 38.61%. When we look at the product from the Optima, you can see that the CV was upgraded to a RB2 specification at 26.45 megajoules per kilogram and an ash content of 16.85%. The discard, as Christina mentioned, that was fed to the SX10 had a CV of 12.78 megajoules per kilogram and an ash of just above 50%. So the overflow product at RB2 specifications was obtained at more or less 43.8% mass yield. When we look at the product that was produced and we look at the yield and CV and ash curves, it can also be seen that if need be, an RB1 product is achievable at 27.81 megajoule per kilogram and an ash below 15%. But unfortunately, you then have to compromise on yield a little bit, where the yield will now be 35.5%. So if we look at the circuit as a whole, just to summarize, the Optima produced a product of 26.45 megajoule per kilogram at a 43.8% mass yield. And then the Spiral produced an ESCOM product from the Optima discard at 43% yield, which relates to an overall circuit yield of 25.5%. So something that I would like to take your attention to is the discard, the overall discard of the system. The discard had a CV of 5 megajoule per kilogram and had an ash of above 70%, which shows us that we took more or less everything from this feed coal that we possibly could. The overall yield for this circuit was 69.26%. So what does this mean in a real life situation? So what we did was to evaluate a circuit based on 40 tons per hour of the feed, and we assumed that that feed would have 20% slimes. Based on this, we found that it is possible for us to produce 14.02 tons per hour of product 1, which is RB2, and 8.15 tons an hour of an ESCOM product. So when we base this on 500 operational hours per month, we find that product 1 would obtain a revenue of 5.6 million rand, and product 2 would obtain a revenue of just above 1.5 million rand, which gives a combined revenue of 7.15 million rand. So when you look at conventional circuits where you produce just one product, and in this case we evaluated the ESCOM product, you see that the revenue obtained from that is 4.2 million rand, where it's almost half less than when you use these technologies to complement each other. So to conclude, both the Optima and the SX10 showed the ability to upgrade the feed to a RB2 product with a CV of above 26 megajoule per kilogram. However, the Optima did show a significantly higher mass yield in the product, which was almost 14 or around 14% more than that of the Spiral. So when we evaluated the spiral to produce an ESCOM product, we saw that the spiral could do that relatively easy with a product mass yield of 45.3%. Therefore, the best configuration to produce two products, which is export and ESCOM, was where the Optima was used as a rougher, followed by this spiral that produced your thermal coal for ESCOM. In this circuit, it was shown that the combined product yield was 69.26%. And therefore, based on this, we saw that the circuit has the potential of almost doubling your revenue just because you have a diversified product range where you produce two products instead of one. So future work that we would like to include in this is to evaluate the washability of the product, to determine the optimal cut densities of the units, as well as the organic efficiencies, which would then lead us to further improve and optimize this circuit. Thank you.
Thank you. Thank you, Christina. Thank you, Franco, for the presentation. I think it's I had a question, but you already answered it just now, Franco, on what the configuration would be, the best configuration there. Okay. Alrighty. I think we have a few questions here. Okay, the first question is from Colin 46. Is the Optima similar to the TBS, UCC, and just a hindered bed settler, or just a hindered bed settler? What is the differential to the others?
Thank you so much for that question. So just to give clarification on that, the Optima classifier is, as the name suggests, a classifier, but where it fundamentally differs from your normal TBS or your normal T-type classifiers is in the design of the body, where your normal classifier would have 1 unit width of a body. The Optima classifier has 2 unit widths. So your main separation zone is in your less or in your smaller unit width area, and then you have a recovery zone on top of that, which has a bigger diameter. So as I mentioned, that bigger recovery zone enables you to prevent short circuiting of heavies, so that which is definitely not present in your normal T-type classifiers or your TBS classifiers. And that also then enables you to better control your unit for a density set point rather for classifying or a size cut point. I hope that answers the question satisfactorily.
Thanks, Franco. I think we'll basically maybe just check if it's possible to put a picture or a schematic of the unit when we post it on our website. Okay, next question, I think it's from Yuri. Have you installed this combination in an operation? And has the SX10 spiral been accepted by industry and installed?
Okay, so let me just start by answering about the SX10. So the SX10, there's no difference in terms of the profile to the SX10 to our normal SX7 spiral. So the only difference is the height. So to answer that question, the SX10 is well accepted. There are, however, restrictions for some existing installations because the SX10 it's quite taller. However, the profile and everything, it's not significantly different to the already accepted spirals that we have on the system. And regarding the combined circuit, well, there is an existing operation that has the Optima and the Spiral in combination running. And however, the cleaning on the spirals, it wasn't with the SX10, but it was with the MX7. We do have an existing installation like with the combo.
Okay, and then maybe just to follow up on that, Christina, in terms of the installation, obviously retrofitting the unit into an existing spiral circuit, how easy is it?
It's, well, it depends. I think I mean, if you look at like the dimensional differences, so your MX7 or SX7, in terms of height, they would be around 3.8, whereas the SX10 would be around like 5 meters tall. So as long as there are no height restrictions like within the plant, this can actually be retrofitted. Yeah, obviously, depending if there are some steel structures, there might actually be some modifications that are required. But then to be fair, I think it's a lot easier for a plant that has not been built. But these are the things that can actually be worked around, like if the SX10 is desired.
Okay. Another question from Vay. Do you have a test rig to use on a site or to send a sample for testing?
Yes, we actually do have a test rig at Multitech. We do have a test rig where we can test most of our spirals. And Gravitas also has a test facility where the Optima can actually be tested. So the pictures that Franco showed there on the presentation, that's exactly the test setup that Gravitas has like at their facility.
Yeah, so just to add on to that, Christina, thank you for that. We do, as Christina mentioned, we have a small, I won't say lab scale because it's a bit bigger than that lab scale, but it's not at pilot scale yet. We do have a test unit there. And then we also have a site-ready test unit that does around 4 to 5 tons an hour that we could take to site and actually add a stream into the Optima to see what it does on site.
Okay. So currently, if you want to send a sample to one place where the test can be done, that will be at Gravitas because you've got both of them there already.
Okay, so Gravitas, well, we don't have like an extensive range of our spirals. Like we still predominantly do all the spiral related work here at Multitech. But in terms of how we operate, we collaborate very well. It shouldn't matter where the material has been received. So if the material is being received at Multitech, preparation can actually happen, and then we do the part of the test work on spirals at Multitech, and we transport the product or whatever part of the material that needs to get tested to Gravitas, and vice versa. Yeah.
Okay. All right. Okay. All right, I think those are the questions that we had for today. So I think thank you very much, Christina and Franco, for basically giving this presentation again. It was great, and I would also like to thank everyone for attending today's session. Unfortunately, we are still not able to share drinks and have further interactions, which is something that we always, look forward to. But we hope that we will be able to have face-to-face technical meetings very soon, which we should be communicating as soon as we all get a go on that. So I would like to have basically just wish everyone a productive day further, and see you in our next meeting. And also remember, the presentation will be available as soon as it gets uploaded onto YouTube. So look out for it. Thank you very much, everybody, and yeah, bye.
Thank you.
Okay, thank you.
Bye.
Bye.
Thank you. Bye.